Today's lesson is on how do we find distance in the coordinate plane. Given the following coordinates, a, -2, 1, b, 3, 4, and c, 3, 1, find the perimeter of the shape. Take a second to copy down the question. I'm going to start by plotting the points. My first point is -2, 1, and that's point A. Point B is at 3, 4. And point C is at 3, 1. So when I connect these points, I have a triangle. If I need to find the perimeter, that means I need to find the distance around the entire triangle. My first line, this BC, is easy to find. That's 1, 2, 3. The distance from A to C is 1, 2, 3, 4, 5. And then finally, I need to find the distance from A to B. Since this line from A to B does not fall right on the grid, I cannot just count the boxes. But if I notice this shape that gets formed, since I have this vertical line and this horizontal line that meet, it forms a right triangle. So this shape would be a right triangle. And this would be my hypotenuse because it's opposite the right angle. So I have 3 squared plus 5 squared equals c squared. 3 squared is 9. Not 9 squared, just 9. 9 plus 25 equals c squared. 9 plus 25 is 34 equals c squared. To get rid of the c squared, I need to take the square root of both sides. The square root of 34, I'm going to round my answer to the nearest tenth, is 5.8. So that would be c. So this side here would be 5.8. So if I wanted the perimeter, I would just add up all those sides. 5 plus 3 plus 5.8. And when I add up 5 plus 3 plus 5.8, I get 13.8 as my answer. That would be the perimeter of this shape. And the next problem. Find the perimeter of the following image. Take a second to copy down the picture. So again, if I need to find the perimeter, I need to find the length of every side. This first side, from x to z, would be 1, 2, 3, 4, 5, 6. Now I have to find the distance from y to z and y to x. In both of those, I notice that they're not perfectly on the grid, so I cannot just count the spaces. In order to find this distance, and in order to find the distance between any 2 points of a coordinate plane, I can just form an imaginary right triangle wherever I want. So I can use these dotted lines to create a right triangle. A right triangle in the coordinate plane has to contain a perfectly horizontal and vertical line, and then I have my right angle here. And then from there, I can just count my spaces. This up top part, it would be 1, 2, 3. And then on the side, I would have 1, 2, 3 as well. And this would be my hypotenuse because it's opposite my right angle. So to find that, I would have 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. 18 equals c squared. I can take the square root of both sides. In order to do that, the square root of 18, again, I'm going to round this to the nearest tenth, would be 4.2 equals c. So the side from y to z is 4.2. Now I also have to find the distance from y to x. Again, since that's not a perfectly straight horizontal vertical line, I can't just count the spaces, but I can create another right triangle on this side. Here's my right angle. So this side that I'm looking for is C. The distance on top is 1, 2, 3. The distance on the left-hand side is 1, 2, 3. Since this is the same right triangle, I know that the distance of this hypotenuse would be the same, and it would be 4.2. So now to find the perimeter, all I'm looking at is my black sides. The red sides from my right triangle are not part of my perimeter. So my perimeter would be 6 plus 4.2 plus 4.2. So I would add up those three sides. 6 plus 4.2 plus 4.2 is 14.4. So my perimeter would be 14.4.